Now, on Thursday, we started our discussion on object-oriented design, right? And we started talking about what an object is, and we understood that an object actually consists of, or it has to begin with, two important things, which is the data itself and the logic, right? And these objects also talk to each other, so they communicate with each other, and they also have a third thing, which was, do you remember that one? They also have an identity, right?
Yes.
Right.
Identity.
The identity. So the recording has started. Perfect. Okay. So this is something we looked at on Thursday as well. For example, we said that Apple is an object, and I forgot to turn on my camera as well, because let me do that. Let me just. Okay, because I like to, show my expressions and let you understand the key points here. So we looked at Apple and we said, yes, Apple is an object, right? And we also said the mug or a cup is also an object, and we had a good discussion about it, and we said that we understand that these two are objects, yet we are able to separate from each other, from each other, because they have their own identity. So what are the three things we know now for an object based on our discussion so far?
Identity and logic.
Identity and data and logic.
Yes.
Okay.
And communication to each other.
And they do communicate with each other, absolutely. And the reason they communicate with each other is so that they can share information and actually do the logic of the work, or the basic, the requirements or the features of the function of the application. Now, we also said that yes, we understand that these are two different objects, and we don't never get confused about them. And the reason we never get confused about them is because we know that they have similar attributes and behavior, but so of course they have the same behavior, but they are different objects because they have their own unique identity. And we also, and I think this is where we stopped the other day, we also said that an object could be complex objects as well, because it could be an Apple, or it could be an aircraft, or it could be an iPhone. So we never get confused about them, that iPhone is a different object than aircraft. And we also never get confused in a sense that, and when someone says I'm talking about the screen of an iPhone, it's everyone is absolutely clear about this concept that he's talking about a touch screen in an iPhone. Now we know that, and I think this is where we stopped. We know that objects have characteristics, right? So they actually they have certain inherent properties that describe them. For example, what could be the inherent properties of mugs? What could be the properties of mugs?
It can contains liquids.
So it contains liquid, like for example, the mug I have at the moment with me, right? Or anything else?
It has a handle.
It has a handle, yeah, absolutely right.
Color,
any other
size.
property it could have?
The material made of.
The material it's made of. And list can go on, right? So for example, it can be like, a mug is full or empty, is it cold or hot, and so on and so forth. And similarly, what about apple? What could be the inherent properties of an apple?
Color, maybe.
Its color, absolutely, absolutely. It could be a red or a green, right? Or its taste, right? Or a flavor, right? So all objects have inherent properties. And basically, these are the attributes of an object, right? That's something you guys do every day when you write classes, right? So it could be color, it could be weight, it could be size, and the most important point to understand here, and I like your special attention for this point. objects, their attributes actually does what? They describe what? Current state of an object. What I mean by this?
Properties can change.
Absolutely, properties can change. For example, in case of a mug, how the properties of a mug can change?
If it became empty, maybe.
Absolutely, it's full at the moment, and a few minutes later it could be empty, right? Or it could be empty and it becomes full, so and so forth. So attributes of an object always describe the current state of an object. Okay, this is a very important concept to understand. Of course, most objects have multiple attributes, right? So for example, this mug could be full or an empty at a certain time, while it at the same time its color could be black or a white, right? And it could be a small mug or a larger mug. Okay, so as it happens in the real world, an object, so will happen in our object-oriented code and design as well, is that these classes will have attributes, and at the end of the day, the attributes values for objects can change or will change for sure. But the key point to understand here is that the attributes of any object actually describe the current state of an object. Okay, so let's move forward then. In a real world, of course, objects do have behaviors as well, right? So it's not just the attributes they also have behaviors. And that's why when you create classes, even in your 1 or 2 ICS 1 or 2 days, the very first thing you do is you create a class and you have the attributes and methods in it, right? Now, the reason I'm taking you from this journey is because I want you to be absolutely clear from a design perspective, right? So far, you know that an object has an identity, it has a logic, and it has a data in it. And when you are creating these objects are all unique objects, though they can be of the same type, and each object has a set of attributes, and those attributes represent what?
Its current state.
Current state, absolutely. Now, in addition to attributes, they also have behaviors. For example, a telephone can ring, an airplane can fly, and these behaviors are very specific to a type of an object, right? And we are, subhanAllah, based on our experience and learning, we know that, for example, an apple will never ring, right? While a telephone doesn't fly, and so on and so forth. So we never get confused about these things. In other words, these behaviors are given to an object or assigned to an object which makes sense from their perspective. All right. And this is exactly what we do in our design as well. So the 3 things we have are identity, attributes, and behavior. And together, these things help us describe an object in an object-oriented programming language. Right? Everybody's on board with me on this?
Yes.
Yeah, it's clear.
Okay, perfect. Now, last thing before I move on. The behavior is specific to a type of an object. For attributes, I said what? They represent
Current state.
Current state of the object. And now I'm saying that for behavior, it actually represents the type of an object. Is this point clear?
Doctor, can you repeat, please?
Yes, please. Attributes. When we talk about attributes an object, we talk about that it will describe the current state of an object, right? So for example, if I have a mug, the current state of one of the attributes of the mug could be whether it's empty or not, right? So it's a Boolean, for example, right? Is it empty or not? And for a current state, given this time, it will say it's not empty, but maybe after a few minutes, it will become empty, right? So at a given time, it always, the value of an attribute always represents the current state of an object. While the behaviors are specific to an object. In other words, you know, if I have a, for example, a telephone, then if I create a million objects of telephone, right? It will all have the ringing behavior in it. Right?
Right.
Okay, so let's move on then. From a no, because this is so far it was very abstract or non-technical, you know, examples I was showing. But from a computing perspective, they are basically the objects. Now someone asked you what is an object from a computing perspective, and this was the question we started off on Thursday. They are all self-contained, and they have identity which separates them from other objects, right? So each object in a computing term has an identity, it has its logic, it has its data. In other words, it has its own attributes which represents the current state of that object, and they have their own behaviors. Example. We have how many objects we have here?
3.
We have 3 objects.
3.
One is a bank account object, while we have 2 objects of type person, right? Each one of them have their own unique identity. This is the first thing. They have their own attributes. So they have their own attributes. First of all, they have their own unique identity. This is how we know that this object of person is different from this object of a person. We never get confused about this. Or the computer doesn't get confused about this. This is one thing. Second thing is, of course, they have their own attributes, which are representing the current state of that object. So in other words, at this moment, this bank account has a balance of $500 and a certain account number, right? While the object person, this one has name value Bob, while this one's name is Alice, right? And this is a male, and this is this is a she, a female object. Correct? See, it has a current state. Now, of course, tomorrow you can go on and change this value to 700, and that will be the current state of that attribute or that object. Similarly, of course, we have their own, they also have their own behaviors. For example, in a bank account, you can go and deposit or withdraw money, while in a person object, you can go for walk or a run. Right? Is this concept clear? I mean, this is something similar, and this is sorry, I should say this is something you guys do from your ICS 1 or 2 days anyway.
Yes, it's clear. Thank you.
Yeah.
Go ahead, please. Any questions before I move on? Let me check. Yeah, what about the identity? Is Salim, is this clear now? Okay, perfect.
Can you explain identity more, because I'm confused with
Okay.
quality.
Okay. Now, identity is something when you create an object, at the end of the day, a unique identifier is assigned to it if you look from a programming perspective, right? So it's given a unique identifier by the system, and that's why when you say, for example, you create B1, right? And this is B2. So if you do certain manipulations of B1, this never gets changed, correct?
Yes.
All right, so this is kind of your unique identification. This is how you manipulate them.
So it's like the name, right? Person
Yes.
and
Yes. Yes. So the identifier. Any other questions before I move on? Seems to be fine. Good. Now, of course, in computing terms, we can take the concepts of object further from these real world entities. For example, we can create a class or an object of type date or time or bank account because they're all objects, right? In a real world. So for example, one bank account is separate from another because it can have its own attributes and it can have its own data, right? Which is the current state of an object, and it has its own behaviors, which are basically about deposit and withdraw. Something we just saw, right? So it can have its own values. Tomorrow I can create an account. So this could be account 1. I can create an object of account 2, and it will have its own set of attributes and behaviors. Of course, the behaviors will be same, attribute names will be same, but the values will reflect the current state. Okay. Of course, objects are not always physical items. We all know this because we can create objects for non-physical items because we need them to solve a specific problem for an application we're developing. What is a non-physical object here in our example?
Bank account.
Absolutely, bank account, right? Okay. Abdul Majid said person X is equal to X is an identifier here. Yes, absolutely. Yep. Now, of course, what's a class? Again, you guys do this from your ICS 1 or 2 days. Objects and class go hand in hand. They cannot be without each other. We cannot talk about one without talking about the other at all.
An
The entire,
instance?
yes, please.
It's an instance of an object.
It's an so basically, a object is an instance of a class, right? So the entire point of object-oriented design is about objects, but of course, at the end of the day, you are creating classes to create objects. So we need to use classes concepts to create these objects. We cannot create classes, or we cannot create objects without creating classes. And a class describes what an object will do. It's not an object itself, and this is something we all know, so I don't need to spend too much time on this. So for example, as a builder can use this design, this specific design to build a house. For us, we write a class, right? And then we use these classes to create objects. And this is something you guys started doing it from your very first programming experience with Java. You started creating classes, and from there you started creating objects. But I'm hoping that inshallah after today's and and Thursday's discussion, the concept is more clear that why we are interested in creating, when we create classes, why we are interested in creating their attributes, why we are creating their behaviors, right? Because at the end of the day, we want to create objects out of them, and these objects we need to somehow represent their current state, which will do it in your attributes, and of course they will have certain behavior. So as, like for example, designers can go on and use the same design to create 1 or 2 or hundreds of thousands of houses. We can also do the same thing, and this is something you guys do it every day when you do a Java programming exercise. Basically, you create class once, and then you can go on and create thousands and thousands of objects of this one. Now we know that when we can create an object, it will have its own identity, it will have its own attributes, and it will have its own behavior. And attributes will present the current state of the object, and behavior will present the overall behavior of that specific object. Of course, at the end of the day, we are creating objects, but classes come first. Now, this is something I'm pretty sure everybody is very comfortable about, correct?
Yes.
That's why I went a bit faster here, because I'm very sure everybody is very comfortable with these concepts. So as a simple example, we have a class bank account, right? What are the attributes here?
Account number, balance, date opened, account type.
Exactly. And these are our behaviors. And we can use this class to create multiple objects, right? So we can create a Joe account object and an Alice account object and a Sam account object. Each one of these objects now has its current, these attributes show, or the values of these attributes show the current state of that object. So for example, Joey has 500 balance while Alice is -50 and Sam has 7,500. All of them have same behavior. Right? Basically, you have instances of these class. And alhamdulillah, I'm very comfortable and confident that all of you know these concepts when it comes to, how to create classes and how to basically, create objects out of them. Now I'm going to move on, and I like your special attention here now. I'm going to talk about certain fundamental concepts in object orientation. And I'm going to talk about the concept of abstraction. I'm going to talk about polymorphism, and I'm going to talk about inheritance, and I'm going to talk about encapsulations. Actually, I'm going to talk about abstraction first. If we have time today, but I'm going to talk about encapsulation. Then I'll talk about inheritance, and at the end, I'll talk about polymorphism. As I said a moment ago, I like your special attention here. Of course, due to this online mechanism, I can't see you guys, but I like your special attention here because if you understand these four concepts, then all the other detailed design concepts I'm going to teach with principles of creating good designs and design patterns and all of that stuff actually revolve around these four fundamental concepts: abstraction, encapsulation, inheritance, and polymorphism. So let's dig into it. All right. What's an abstraction before I talk about this? What comes to your mind? What is abstraction?
It's generalization.
It's a generalization. Yep, absolutely. Any other thing comes to mind? What's an abstraction?
Doctor, do you mean the class abstraction, right?
Yeah, the class abstraction, yes.
Okay. It's a class without specific behaviors.
Okay. Yeah, I thought so. No, I'm not talking about abstract class. No, I'm not talking about abstract class here. I'm talking about the concept of abstraction. I'll talk about abstract classes inshallah later, but I'm talking about the concept of abstraction in an object-oriented design.
I think common behavior, maybe.
Maybe, yeah, common behavior, maybe. Yeah, go ahead, Omar.
Something that does not exist in the world, but it exists in our mental, in our brain.
Okay, yeah. I know what you're saying. Yeah. So it's like a concept, right?
Yes.
Yeah, something which we can visualize. Yep. Anybody else would like to share? A couple of more concepts, because I want to understand what's the feel of the class today for the concept of abstraction.
Doctor, maybe I think, I'm not sure, maybe separation of concern.
Separation of concerns.
You try to split objects into as detailed, as possible, and they don't communicate with each other. They use the states.
Why not? Yeah. One lucky last, guys. One lucky last. Feel free. I want your participation here, to be honest. I want to understand exactly what people are thinking about abstraction.
So when we had like a big problem and a complex one, when we divide it and we look clearly for like specific thing, that complex thing, it's abstraction.
Okay. Yes, why not? Alshan, I think you raised your hand. Go ahead, please.
Yes, is it like a general idea rather than actual person or the object itself?
Yeah. So that's a good observation here. Okay. So let's now, I'm going to start off with an example here with you guys. And inshallah, I'm going to use this to build the concept for us. Right? Now, let's start and look at abstraction. Special focus, guys. Now, if I say to you that I have a table, what comes to your mind?
Columns and rows.
Columns and rows. Okay.
Desk.
Desk. Yep.
4 legs.
4 legs. Yeah. Yeah, go ahead. Go ahead. So I'm saying I have a table. Are you, what is your visualizing in your mind?
There is an order.
Okay. So let's say, for example, yeah, go ahead, go ahead. Yes, Nawaf, please.
Entities.
Entities, okay. So let's say I have a table and I'm talking about a physical table now, for example. So what exactly is coming to your mind now? Because I'm pretty sure everybody has some concept of a table in his mind now, right? So as someone says, 4 legs, desk, right?
Flat top.
Flat top, yeah. Few more. Because this is, I want you to express your thought here, because a flat surface with 4 legs, absolutely, as Yahya said. Okay, so we have enough information here now, I think so. So as you guys said, some of us thought about, from a computing database Excel kind of idea, right, about a table, correct? That,
Right.
that when I'm saying table, basically maybe we're thinking about, because we're all technical here, so we think about maybe database tables here, right? And some of us said, when I said no, I'm talking about a physical table here, then we said that maybe it's a flat surface with 4 legs, as Yahya said, or it's 4 legs, and some of us thought about a flat top. We can easily think about maybe it's a wooden table, right? We can easily think about maybe it's a coffee table, right?
Yes.
Or a dining table, right? Right, so
Yeah.
when I say table, I didn't say any of this stuff, right? So basically it depends on what I have in my mind at that time, or based on my experience, I visualized the thing, right?
Right.
Okay, so I didn't say anything about wooden table or a glass top table, right? I didn't mention any of this stuff, correct? I didn't mention anything about 4 legs. I didn't mention anything about the top on it, right? But I didn't mention anything about table being small or large. Based on your experience, you all had different visualization of this word table, correct?
Yes.
Correct.
Right. Now, which is fine, absolutely fine to have an image in your mind. It's absolutely okay. Right? Because I was not specific at all, because I don't have any specifics, right? Because I was not specific, hence you understand the table or the concept of table based on your experience, right?
Yes.
And that's why some of us even were thinking about database tables even, right? So the moment I was not very specific, it was up to our imagination to understand what this table is. And all of us were correct, absolutely. Right? Now, what this concept has to do with the concept of abstraction we use for our designs. We're getting there now.
When you are not specific, you are an abstract.
Yes. Yes. So basically, this was the abstraction of a table, right? This was an abstraction of a table. Now, this is for the non-technical visualization of the word. Now, we're gonna now use and build this concept to think about from a design perspective now. So abstraction at the end of the day for us as designer means what? We need to focus on essential qualities of something rather than one specific example.
Doctor?
Okay, so yes, please.
It means we generalization the object.
Yes, 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 yes. Now, since we are doing this, abstraction means you automatic, and this is to be honest, this is the point I like you to again pay special attention, because first was to understand the concept of abstraction when I raised this question of table. Now, this is abstraction with the message I want you to take away from today's lecture is this point. Abstraction means we automatically discard what is unimportant or irrelevant. Right? For example, all of you had different ideas of the concept table, right? You all said to me that, you know, it has a flat surface. Some of said that it has 4 legs. Some of you said it's a coffee table or a dining table, right? But none of you ever said that this table has a flavor, right? Correct?
Yes.
Why? Why none of you said that?
Because in general or mostly there is no flavor for the table.
Yeah, the table doesn't have a flavor, right?
Yes.
Or a flavor or a table doesn't have an engine, right?
Yes.
While if we were talking about the Apple object, will you think about flavor there?
Yes.
Yes.
Absolutely, right? Because it's natural. This is based on your experience. You know that apple have flavor, while table is a non-eatable item, right? So it doesn't have a flavor, right? So the concept of abstraction is what? The concept of abstraction is to automatically discard unimportant or irrelevant information, right? So we have an idea or a concept that is completely separated from a specific instance, right? This concept is heart of object orientation. This is what we use to make a class. When we are making a class, we are designing a class, we use the concept of abstraction to design them and decide whether this is going to be a class or not. And we all know that class is such a fundamental concept that from the classes you create objects. From classes you use the other concept of inheritance, polymorphism, attributes, all of that stuff, right? If you don't have a class, none of them make sense. So it's an heart of your object-oriented concept. The concept of abstraction, which means only focus on essentials and remove irrelevant stuff. Now, what is happening here? I have 2 objects, correct?
Correct.
I have few attributes, right?
Yes.
And of course, I am creating these objects from a class. No rocket science here, right?
Yes.
Right.
Now, will you think about when you look at these apps, these bank account attributes, I'm saying only 2 attributes, account number and balance. Can you think of any other attribute you believe should be there?
The account type.
Okay,
Date.
so maybe account type. Yes, please.
Date.
Date of creation of the account, maybe, right? Anything else?
ID.
ID, account name, so on and so forth, right? Now, again, let's see what's happening here. The concept of abstraction is what? To focus on what?
Important.
Important or essential item, information, right? And discard irrelevant stuff, right? So when we're going to try and apply the
Yes.
concept of abstraction to my example bank account here, I'm always interested in the essentials and I'm going to discard unimportant stuff, right? Now, of course, every account when you create has a date of creation of an account, right? There's no doubt about it. But whether this creation of a date account detail information is required in my problem statement or not will tell me whether I will have that attribute here or not. Is this clear?
Yes.
And the principle I'm applying here to decide this is what?
The abstraction.
The abstraction. Because abstraction tells me what? Abstraction tells me I am only supposed to have essential information. And I'm not supposed to have irrelevant information for my given system. So if an account creation date is irrelevant for my application, though it makes sense to have that attribute, I will not have that attribute in my system.
Doctor.
Yes, please.
Who made the decision that this information is important or not?
You as a designer. Okay. And your source is what? Your source is the requirements.
Okay.
All right. Yes. In other words, what we're trying to do here is that we are trying to use the concept of abstraction to create classes or design classes. At the moment, we're designing classes, right? Because we're all designers now. So we're designing classes, but we want to design a class which we don't want to design a class which has everything in it, everything we can think of, right? Because for a bank account, based on our experience, we can think of many attributes, right? And similarly, we can think of so many different behaviors as well. But we are not interested in having all of that stuff in it. No, I want not to apply abstract concept because I only want to create the things which are absolutely essential here. Cool.
Yes, Victor, I have a question.
Yeah, go ahead, please.
Can we think about the abstraction like a filter? We have everything and discard an unimportant thing.
Correct. Absolutely. That's a good explanation, actually. It's like a filter. Right? So in other words, I'm only focusing on what? I'm only focusing on essentials. And if you do this, you are actually applying the very fundamental concept of object-oriented design, which is apply the concept of abstraction when you're creating classes. Okay? Because if you create your classes correct, then all of the other stuff will fall in its own place from a design perspective. So in other words, as we just had discussion, it might be true that every account was open on a specific date, right? Of course, there's no doubt about it. But if our application does not care about that piece of information, we don't need to have that attribute in my class as a designer. And this decision that whether I should have it or not, whether it's required or not, is concept of applying the abstraction concept. Can I be confident here that we are on board with me? You guys are on board with me for abstraction.
Yeah,
Yes.
Clear now. Yeah.
Sure.
Alhamdulillah, alhamdulillah. So in other words, it is the abstraction that supports other fundamental object orientation design concepts, for example, inheritance and polymorphism and all of that stuff. It will all make sense, right? If we are clear about the concept of abstraction.
Doctor.
Yes, go ahead, please.
The concept of the abstraction is clear, but The last sentence, it's not clear how it supports other fundamentals.
That's a good question. Absolutely good question. Good question. Now, of course, we'll talk about, because I said in the beginning of this section of the lecture that we will talk about 4 different, concepts, right? Inheritance and polymorphism and encapsulation. But since you're raising a question which is important, and of course, inshallah, after this 4 concepts, I'll be asking you again as a class that what's the difference between these 4. But anyway, the point here is that since you're gonna use the abstraction concept to create classes, the inheritance, for example, right? What's an inheritance? What's the concept of inheritance?
Using the parents' attributes.
Yeah, using the parent attributes, right? So if, for example, if a certain child class needs certain attributes, right? And this is only specific to that class, or there are certain common attributes among all the children. This drives your decision of where these attributes will be in your class hierarchy. Do they?
The parent.
Yeah, absolutely. And then the reason you put them in parent, why?
To get inherited, not
To
copy
be inherited, right? Yes. And but why you are deciding to put them in the parent class? Why not have them in the individual class?
Because it's important.
I might have several subclasses that might depend on the functions and the parents.
Yes, exactly. Or they have common ones, right?
Yes, common functions.
Common functions. That's why you put them into parent.
Yes.
And the reason you're putting them into parent, now you're going to apply it. So this is concept of inheritance. We will talk about this inshallah later. But abstraction fits in what? Abstraction is you're allowing you as a designer to include this attribute or in your parent class because it is relevant to your application, right? Because more than one children needs this information. Correct?
Yes, correct.
Is this clear? Let me draw it here for you. I have a parent here. And I have children here, right? I decide to have a certain attribute here because it's required by both of them. Correct?
Correct.
Now, this is with inheritance concept, but abstraction is that you're allowing this to be here in the first place because it's essential. Right? Now, if I say, for example, I have a double star here, this is another attribute, right? And it's not required by any one of them. Would you keep this?
No.
And why you will not keep this?
No.
Because of abstraction.
Because of the abstraction. Absolutely true. Cool.
Yes.
Great.
Cool. Yes.
So see,
clear
these 4
now.
concepts, inshallah, will go hand in hand. And together, we use these 4 concepts to create a class diagram, a class design. Okay. So I think I'm very confident now that we are comfortable with the concept of abstraction. So how much time we have, guys?
4 minutes.
4 minutes.
4
Okay,
minutes.
So probably we cannot really cover much in encapsulation, but I'll show you encapsulation very briefly, and then we'll stop, and then we'll inshallah use Tuesday's lecture to really focus on this concept, the second one. Are you able to see my screen?
Yes.
Yes, we can see it.
Okay. So the very first one was the abstraction. The second one is encapsulation, right? What's the meaning of encapsulation now? What comes to your mind? What's encapsulation?
Grouping.
Grouping them, yes.
Isolating.
Information in specific places.
Okay. Anybody else?
Isolating.
Isolating, yes, absolutely. Okay, so in other words, encapsulation is like these containers, right? You want to group them together, you want to put them separately, right? You isolate them. So the idea of encapsulation in object-oriented design is very much similar to this container example, right? You want to do two things. You just don't want to keep the things together, but you also want to make sure that you protect them as well. So you are focusing on, when you are doing this encapsulation principle, you want to keep the contents together, which is supposed to be together, and you also want to protect them. Okay. So if, for example, and with this, inshallah, we'll stop and we'll use this as a starting point on Tuesday, inshallah ta'ala. So I have a set of attributes, right? Account number, balance date, open, account type. And similarly, I have a set of behaviors: open, close, draw, withdraw, deposit money, so on and so forth. I put them together in a class. Okay. And let's assume I'm applying the concept of abstraction, which means these are essential, right? They are required for my system. Now, what will be encapsulation here then?
Making it private, I think.
Yes, absolutely. Making them private, making them public, all of that, those decisions, right? Those are your encapsulation decisions, or you're applying the concept of encapsulation now. Okay. So with this, I think we're right. I'm almost 10:50 now. So let me take the attendance. I think we'll stop it here. And let me take the attendance, and then inshallah we will continue this on Tuesday, inshallah ta'ala. So it's 10:50 now, so we can stop the class now. It's officially stopped. Anybody has a question? I'm around. Otherwise, feel free to leave, please, for your next lectures.
Thank you, Doctor.
You're most welcome.
Thank you.
Welcome. Anybody has a question? I'm around. Otherwise, inshallah, see you on Tuesday.